Okay, now we are going to find the area of our parallelogram. If the parallelogram has the vertices at 1, 4, L is at 4, 5, M is at 3, 1, N is at 0, 0, and the height from the vertex K to the base MN, okay, let me label my sides, my points, that's K, L, M, N. Alright, and it is saying that I have from the vertex K to MN, and it is at 2.1 and 0.7. So like right there. Whoops. That's the height. Okay, and that's useful because our parallelogram area formula, area of a parallelogram, is equal to base times height. So we have to calculate a base, and it indicates it, MN, so there's our base, and our height. So we have two calculations to make. So first, let's find our distance of MN, our base. MN is going to equal the square root of our horizontal distance is 1, 2, 3, 3 squared. And again, you can work this out completely algebraically just by using the x coordinates and find the distance between them, and then find our vertical, which is 1. So we have 3 squared is 9, 1 squared is 1, so 9 plus 1 is 10. So there is our distance, and it wants it to the nearest 10th. So we have the square root of 10, and we're going to come over here, calculator. Square root of 10 is a 3.16. The 6 is greater than a 5, so we would round that to 3.2. So this is approximately 3.2. Alright, so there's our base, and now we need to find our height. Going back, we have the point, and this is one example where I cannot just use a straight horizontal and a straight vertical, because if you look at my height line, it starts at K and it comes down, and this part is at is slanted, so it's not a straight horizontal along the x-axis. So I'm going to use the algebra to find use the algebra using the coordinates to find our distance. So we have the point K, it starts at K and it ends at point P. So we have the square root of our horizontal distance is still going to be our x values, so x2 and x1. So to find the distance, remember it is the difference between those two. So we have 2.1 minus 1, and that quantity is squared. That's our horizontal distance, plus our vertical distance. Our vertical distance is 0.7 minus 4, and that's squared. So this is going to equal, and here we go. So 2.1 minus 1, and again this is finding our horizontal distance. So that is 1.2. 1.2 plus 0.7 minus 4. That's our vertical distance, and that is being squared, which is, oops, I forgot my parentheses. So negative 3.3 squared. The reason why parentheses are important, I don't know if you caught that, when I square it, it's taking the negative, it's saying that this is a negative 3.3, and it's saying negative 3.3 times negative 3.3. Without parentheses, here I'll show you. If I do it without parentheses, okay, if I do it without parentheses, negative 3.3 squared, it is reading this as 3.3, squaring it, so 3.3 times 3.3, and then it's timesing it by a negative 1 because the negative sign's not inside the parentheses. So that's why parentheses matter when you're squaring a negative quantity. So it is 10.89 because the 9 is greater than 5. This will be rounded to 10.9. Okay. 10.9. Alright, so then we have the square root of 1.2 plus 10.9. And that is 3.47. Because the 7 is above a 5, we're going to round our 4 up. So this is going to be equal to, h is going to be approximately 3.5. Okay, so then we have the area of our parallelogram is going to equal 3.2 times 3.5. So then 3.2 times 3.5, 11.2. Which equals 11.2. Alright, so 11.2, and there we have it. So in certain circumstances you have to write out the algebra to find the horizontal distance and the vertical distance. And in other cases, if you can go along a straight horizontal line, you can count the horizontal distance. If you can go along a straight vertical line, you can count the vertical distance. So there are two ways to do it. Okay, based on our calculations, which one has the greatest area? So 11.2 was the parallelogram, 25 was the square, and 16.8 was the triangle. So the square has the greatest area. And there you go.